Hello, good morning, all of you.
I am Dr. Alok Agarwal, and today is your 16th lecture of course ME 501 named Internal Combustion Engine. So, in today's class, we will discuss about the various factors which affect the volumetric efficiency of the engine. So, in last class, we have studied various different parameters associated with IC engine, and it has been seen that volumetric efficiency is one of the most important parameter, and because of that we are going further into it and we will discuss what are the various factors which affect the volumetric efficiency. Okay, so the factor which affect the volumetric efficiencies are engine speed, atmospheric pressure, atmospheric temperature, compression ratio, exhaust gas in the clearance volume, density of fresh charge, design of the intake and exhaust manifold, and the timing of intake and exhaust pole. So these are the various factors on which the volumetric efficiency depend. So we'll discuss each one of them in detail. Okay. So first, the engine speed. Okay. So volumetric efficiency is inversely proportional to the RPM. What does it mean? That when the engine speed increases, volumetric efficiency will decrease. Why? Because when the engine speed increases, it, there is a less time for charge to come inside the combustion chamber because suction stroke occurs very rapidly, and because of that, less time available to for intake or suction stroke, less amount of oxygen, less volume of air and fuel mixture or charge are getting inside the combustion chamber. Hence, with increase in engine speed, volumetric efficiency of the engine will decrease. Next is atmospheric pressure. Volumetric efficiency is directly proportional to the atmospheric pressure. As the atmospheric pressure increases, the volumetric efficiency of the engine increases. It is mainly because with increase in atmospheric pressure, the density of the charge is getting increased, and with this, the large amount of charge or the large mass of charge can be accommodated inside the combustion chamber. It has been experienced practically also that when the engine is running over the mountain, when the vehicle is running over the mountain, because of low atmospheric pressure, the volumetric efficiency of the engine decreases at high altitude and it starts giving lower efficiency. Okay, next is the atmospheric temperature. Again, it is inversely proportional to the atmospheric temperature volumetric efficiency. It means that volumetric efficiency decreases with increase in temperature. Now let us understand why. With increase in temperature, the density of the charge getting decreases because with increase in temperature, it's try to expand. The gas is try to expand, so its density decreases. And with this decreased density, the mass flow rate decreases, and hence volumetric efficiency decreases. So with increase in temperature, volumetric efficiency decreases. Another parameter is compression ratio. The engine has higher compression ratio, the lower the volumetric efficiency will be. What does it mean? With increase in compression ratio, volumetric efficiency will decrease. So volumetric efficiency, the diesel engine is having high compression ratio and petrol engine is having low compression ratio. So volumetric efficiency of diesel engine is always less than that of petrol engine. And now again, the compression ratio is dependent upon the pressure and temperature. Again, very important parameter on which volumetric efficiency depends is the exhaust gas in the clearance volume. As we have seen that when the piston moves from top dead center to bottom dead center during the suction stroke, the product tend to expand, okay, and occupy a portion in the piston displacement, which is greater than the clearance volume. The exhaust gas at the end of expansion at the end of exhaust stroke, it is not possible to evacuate the complete exhaust gases from the cylinder. So it remains in the clearance volume during the end of the exhaust stroke. And when the intake stroke start, that compressed exhaust gas which is available in clearance volume will try to expand and will capture the volume of the combustion chamber, which decreases the availability of incoming charge, and hence the incoming fresh charge are in less quantity or in less volume, which decreases the volumetric efficiency. So exhaust gas decreases, the amount of exhaust gas present in clearance volume decreases the volumetric efficiency. Next is the density of fresh charge. It has been explained during the temperature part, and it can be related to it. As the fresh charge arrive in the hot cylinder, because of the previous stroke, the temperature of the cylinder is very high. Hence, the fresh charge when arrive in the hot cylinder, heat is transferred to it. Heat is getting transferred from hot cylinder to the charge, and because of that heat transfer, the volume of the charge will increase because its temperature is getting increased, and with this increase in volume, it decreases the amount of the mass of the fresh charge. Okay, and with this there will be a reduction in the volumetric efficiency. So it can be seen that the volumetric efficiency is increases by low temperature and high pressure of the fresh charge, since density is increased and more charge can be inducted. Okay, so density of fresh charge is again play a very important role. Again, the next important part is design of intake and exhaust manifold. The exhaust manifold is to be designed like which will be able to evacuate the maximum possible exhaust gases. Okay, it has to be designed like that whatever the exhaust gases is present inside the combustion chamber, it will be evacuated at the end of expansion stroke, because we have seen that the presence of exhaust gases will decrease the incoming charge, the volume of incoming charge. So exhaust valve has to be designed like that so that it can evacuate the maximum possible exhaust gases. Similarly, intake manifold is to be designed like that it can take the maximum possible fresh charges. Okay, so the design play a very important criteria for volumetric efficiency. So what is the main thing? For increasing the volumetric efficiency, we have to decrease the amount of exhaust gas inside the combustion chamber, and at the same time we have to increase the amount of intake charge, fresh charge inside the combustion chamber. For both the reason, the proper design is required. Next is the timing of the intake and exhaust hole. This is the last factor on which volumetric efficiency depend. As valve timing is the regulation of the point in the cycle at which the valve are open and closed, that we have discussed in valve timing diagram. And it is seen that since the valve requires a finite period of time to open or close for a smooth operation, a slight lead time is necessary for proper opening and closing. So when we are doing that, when we are opening the intake valve before TDC and we are closing it after BDC, it plays a very important role for taking maximum amount of fresh charge inside the combustion chamber, and we have seen that when maximum amount of fresh charge will get inside the combustion chamber, volumetric efficiency increases. Similarly, when we open the exhaust valve just before the end of our stroke, and we remain it open after the piston reaches top dead center at the end of exhaust stroke, it will allow maximum amount of exhaust gases to go outside the combustion chamber, which again increases the volumetric efficiency. So the timing of inlet and exhaust valve is very important. It is always advisable to open the inlet valve before the end of exhaust stroke, and it will remain open after completing the suction stroke. Similarly, in case of exhaust stroke, what is happening? It is advisable to open the exhaust valve before the end of power stroke, and it will remain open after the exhaust stroke. So there will be a time where intake and exhaust valve both will remain open when the piston is at top dead center. Okay, so these are the various factor on which volumetric efficiency dependent, and volumetric efficiency is a very important parameter. Okay, because this defines what are the amount of charge that you are taking, what are the actual amount of charge that you are taking, and on the basis of that only we'll get the power output or the efficiency. So this is all the factor which affect the volumetric efficiency. So this is now for today's topic. In next class we will solve some numerical problem related to the various parameters that we have discussed.